Okay, welcome back. This is a video about section 8.1, which is about solving equations using the addition principle. And so what we want to do is we want to determine whether a given number is a solution of a given equation, and then we want to solve equations using that addition principle. Okay, so first things first, we got to talk about equations. Okay, what is an equation? And it's something, it's a mathematical phrase with an equal sign. Okay, so it's a mathematical phrase with an equal sign. Okay, and that's about it. Okay, that's pretty much all we need to know. We do need to talk about variables. Okay, a variable is a letter in place of a number. Okay, and so typically we use x. Okay, so typically we use x. All right, but we can use any letter. Okay, we can use any letter. Doesn't really matter, but that's what a variable is. So a variable is a letter in place of a number. And you know, what I want to think about, is this. My first teacher said this. They said, okay, let's say that you have some number, okay? And let's say that you put a triangle there. All right, put a triangle plus like 4 is equal to 6. Okay, so this triangle is a number. All right, and we can kind of like think intuitively about it and say, all right, well, what is that number? What number plus 4 is going to give us 6? And that's the question that you ask yourself. And so, that triangle would be equal to 2. All right, and the reason why is because if you took 2 plus 4, it's going to give you 6. 2 plus 4 is 6, and 6 is equal to 6. That's a true statement. All right, so let's go through and let's talk about what that solution to an equation is. A solution is something that makes the equation true. Okay? So it's a number, okay? It's a number that, well, here, let's just do it. All right? So what we want to do is we want to determine where 7 is a solution to the equation x plus 6 equals 13. So what I want to do is I want to say, okay, I have x plus 6 is equal to 13, okay? And I want to know, is x equal to 7? Question mark, all right? So what I do is that if x is equal to 7, I do what's called substitution, and I plug 7 in for x, okay? And I say, okay, is 7 plus 6, is that equal to 13? Okay, and 7 plus 6 is in fact, yes, 13, and 13 is equal to 13. When I get this statement that 13 is equal to 13, this is true, okay? And a solution is something that makes the equation true. So yes, this is a solution. So yes, x is equal to 7, okay? And that's what we want, all right? Now let's take a look at something else. Let's determine if 19 is a solution of 7x equals 141. Now, when you see 7x like this, you're really taking 7 times x, okay? This means when you see a letter next to a number, this means that you're multiplying, okay? 7 times x equals 141. So then the question is x equal to 19? Question mark, okay? So what I do then is I take 19, and I plug it in for x into that equation, and I evaluate it. So I do 7 times 19. Is that going to give me, is that equal to 141? Okay, so then 7 times 19, all right, let's do that. I have to do that in the calculator. 7 times 19 is going to give me 133. So 133, is that equal to 141? And no, this is a false statement. These two things are not the same. 141 is not the same as 133. So because that's false, okay, then x is not 19. Okay, so or you could say that 19 is not a solution to that equation. All right? So we're looking to see, what could we do, are these solutions? Just plug it in and evaluate and see what you get. Okay? So the addition principle. Okay, let's talk about this for a second. What I have, let's think of a true statement. Okay, I'm 31 years old. Okay, right now as I'm making this video. So 31 is equal to 31. All right, that's a true statement. Okay, I can say that 31 is equal to 31. Now, what I can do is I could say, all right, well, I could also what if I add 3 to this side, okay, and I'm going to draw a little line underneath, okay. Then I get 31 plus 3, and I add these numbers vertically. I do actually do the math here. So 31 plus 3 is going to give me 34, okay. So then the question is, in order to keep this balance, in order to make this a true statement down here, if I add 3 on the left side, I also have to do that on the right side. Okay, and I have to add 3, okay? So then I add vertically, and I'm going to get 31 plus 3, which is going to give me 34. Okay, and we remain true, okay? Now let's do that in another sense, okay? 31 is equal to 31. Okay, if I were to, say, subtract, 4 from that left side of the equal sign, okay, if I do 31 minus 4, then that means, what am I going to get there? 27? Okay, so I would get 27. So what do I have to do to 31 on the right side of this equal sign in order to keep this balance, to keep this as a true statement? And what I have to do is I have to also subtract 4 from that side, and it gives me 27 as well to make this true. Okay, so the addition principle means you can add or subtract. Okay, so you can add or subtract numbers on both sides of the equal sign to keep it true. Okay, numbers on both sides of an equal sign to keep it true. All right, and you're probably wondering hey, why do I need to do this? Why are you telling us this? This is what we do to solve an equation, okay? To solve each equation, make sure that we check our answers. So we've got 4 of these, and I'm going to kind of do the same thing for each, okay? Now, what I'm going to do is I have this equation, x plus 5 is equal to negative 7. Now, we're not checking to see whether we have a solution. We have to find the solution. So we have to actually calculate what x is, okay, or whatever variable that we're using. All right, so now what I have here is I have this phrase, and when I read this, I say some number plus 5 is equal to negative 7, okay? And when I do this, when I see it like this, I have to do something to get x by itself, and that's the idea, is that we're trying to use operations to get x by itself. And when I solve this equation, I want to do the opposite. So what I would do is I have this plus 5, okay? And in order to solve this, I want to do the opposite of adding 5. And the opposite of adding 5 would be to subtract 5. But if I do it on this one side of the equal sign, I have to also do it here. And so I'm going to do the same thing here. I'm going to subtract 5. Now, the cool thing is that, at this point when you do that, you actually have to do the math here and say, okay, if I have plus 5, positive 5, and I subtract 5, what's 5 minus 5? That's going to give me 0, okay? And when I do that, this becomes 0. Keep my equal sign lined up, and I put a plus and x. Okay, and then I have to do the math over on this side. And I say, okay, what's negative 7 minus 5. And, if I've got two negative numbers, 7 plus 5 is 12, make it negative, this is just going to give me negative 12. Okay, now if I do x plus 0, some number plus 0, that's just going to give me x. And it's going to stay as x. And x is going to equal negative 12. Okay, so what I've done is I've solved for x. And the goal is to get this down to, x equals some number. So the goal is to get to a point, get to where you have x equals a number. All right, where x is completely by itself. Okay, and so what we always do when we're thinking about equations is we do the opposite. Okay, so let's rewrite. I'm going to write that way up here. Solving equations. Okay, we want to think about opposite operations. Okay, so opposite operations. All right, and we think about ourselves. Okay, what's the opposite of addition? It's subtraction. Okay, and so we use that to solve these equations. All right. So that's what we've got. All right, we want to calculate what x is. All right, so get to where x is equal to a number. Okay, but then we also have to check. Okay, so let's check this. All right, so if we check our answer, think about x plus 5 equals negative 7. I usually rewrite that, and we get that x is equal to negative 12. All right, so what I do is I do what we did before, and I plug in negative 12 in for x, and I evaluate. Okay, so I write this as negative 12 plus 5. Is that equal to negative 7? Okay, and if I take negative 12 plus 5, then yes, this in fact does give me negative 7. All right, so I get negative 7 is equal to negative 7, which is true, and that means that x equals 12 is correct. Okay, that is our answer. So when you're solving equations, there's a way to figure out if you're right or not. Okay, you don't have to do anything. All right. All right. Now let's take a look over here. Some number a, and this one's a little bit easier to do, a little bit more easier to think about. Okay, what I would say is this: I would say some number a minus 4 is equal to 10. Okay, what's that number? And you can think intuitively. Okay, if I subtract 4 from a number to get 10, where do I start at? And that number would be 14. Okay, so we kind of already know what the answer is, okay? And that's kind of how I want you to think. These equations will get more complicated as we move through the class, but right now, you can ask yourself that question and just, be able to figure out what A is intuitively and just kind of think about it. But let's do it. Let's do the algebra, okay? So if I have A minus 4, okay, then what's the opposite of subtracting 4? If I wanted to get a by itself, I need to move this negative 4 to the other side. So the opposite of subtracting 4 means that I add 4. And if I do it to one side, I have to do it to the other. Okay? And so then here's what happens. What's negative 4 plus 4? That's going to give me 0. So this we can just cross out. All right, when you do that. And then you write a below that, keep your equal sign underneath that, and then you get 10 plus 4, which is going to give you 14. Okay, pretty easy, not too bad. All right, so now, but let's do this. Let's check. Okay, let's verify that this works. So let's write a minus 4 is equal to 10. Okay, let's plug in 14 for a and see what we get. So 14 minus 4, are we going to get 10? Well, 14 minus 4, that's just going to give me 10. All right, 10 is going to be equal to 10, and that's true. Therefore, a equals 14 is the right answer. All right. Now notice how we didn't use x, okay, in this example. All right. If I write a minus 4 equals 10, think about it like this. What about x minus 4 is equal to 10? Okay, if I were to add 4 to both sides and solve this equation, all right, negative 4 plus 4 is 0, so you just get x down here, and that's going to be equal to 10 plus 4, which is 14. So you get the same thing, okay? And that's the thing about algebra is that, what we're doing here is we're representing numbers as letters, But, you know, the concept of me doing what I'm doing is no different from either side, okay? I'm doing the same operation, it's just I'm using different letters, okay? And that's something that we kind of got to get past, all right, be able to do. All right, let's take a look at the bottom one. And this one we're using t, okay? And we can, all right? It doesn't have to always be x. Typically, I'll use x. If I'm ever, like, you know, doing a problem on my own, I use x, but sometimes I don't. So this is t minus 3 is equal to 19, all right? So what's the opposite of subtracting 3? Okay, let's move that negative 3 over and get t by itself, okay? Or we can just think intuitively about it. Some number, I subtract 3, I get 19. What's that number going to be? Oh, it's going to be 22, all right? 22 minus 3 is going to give me 19, but let's do it algebraically, all right? So if I add 3 to both sides, okay, negative 3 plus 3, that adds to 0, okay? That goes away. So you're left with t on the left side, and then 19 plus 3 is going to give me 22, okay? So now what I want to do is I want to check this, make sure that we're right. All right, so let's check, and I'm going to do 20, let me rewrite this. T minus 3 is equal to 19. And then I'm going to do 22. I'm going to plug in 22 in for t. And so 22 minus 3, is that going to equal 19? Okay, and 22 minus 3 is 19. And that's 19. So 19 equals 19. That means that we're true. Okay, that means that 22 is our solution. Okay. All right. Do another one. Okay, these numbers are a little bit bigger. We're use t again. They use t a lot. T usually stands for time, and so you know, we figure out what those are. So we use t a lot. You know, t and x are usually the letters we use. But t plus 17 is equal to 53. Okay, so if we're adding 17, okay, to this, to t, the opposite of adding 17 would be to subtract 17 from both sides. Okay, and so 17 minus 17 becomes 0. We cross that out. And then we get that t is equal to 53 minus 17. When am I going to do that? 53 minus 10 is 43, minus another 7 is 36. So t is equal to 36. So then what we do, you know, we check this. All right, let's check and see. And so we get 36 plus 17. Is that equal to 53? All right. If I take 30 plus 10, that's 40. 6 plus 7 is 13. 40 plus 13 is going to give me 53. Okay, so 53 is equal to 53. This is true. Therefore, 36 is our solution. Okay, so hopefully you've seen this before. This shouldn't be very new to you. You know, you've seen it at some point in your math career, but you know, from now, you know, this is kind of a standard practice. Okay, so I hope you enjoyed this video, and we'll see you soon. Thanks. Bye.